We have seen how to calculate the center of gravity using the area moment. So simply what you do is you do take moments for each of these small mass of this entire body, and then that would be exact same as the total body weight in its center of mass like this. So we have done this before. In the previous video, we explained that. So here in this video, we'll be talking about Centroid. Now, let me show you before we talk about Centroid. So if you look around construction material, the white flange beam or some wood section, they're all very symmetric. They're uniform. So when you calculate the weight using the volume and the density, you can actually cancel a lot of those constants like the gravity constant, the density of the material, and you can express this mass moment using simply area moment, cross-sectional area. So you can do simply summation of all small area and its center of gravity. That will be same as the total area and its total center of gravity. So AI, YI, that will be exact same as total area times the y bar. So, however, when you do this is called then centroid. You get exact same point by doing either of these, and this is called center of gravity. And therefore, sometimes they are interchangeable. Now, in this example, what you're seeing here is called a stressed limo. You probably heard about it. So basically, what they do in a stressed limo, they use a large SUV and then they cut into two pieces. Like this one is an Escalade, so they cut in the middle and then they insert a section in the middle. And you see these two guys, they are actually attaching to, they cut this big car into two pieces, probably an SUV, and then they are basically attaching a section in the middle so that they can have a very long stress limo where you can put all the fancy luxury stuffs in there. And sometimes the load calculation are not really done properly. They are famous for collapsing from the middle. So in this example, we are actually doing that. So before you do any load calculation or load analysis, how much some structure can take, you have to know the center of gravity. That is the first step of doing any load calculations. In this video, we'll be talking about how to find that. In fact, we'll be doing centroid because of these common basic shapes they're doing. So here you got these two white flange beam, W10 by 12, and then you have a half-inch thick sheet all across this bed. So half-inch thick sheet here, and then you have this beam here. So we're looking at a cross section across somewhere here. So you're just looking at the cross section area there. So very simple. You can go back to the back of the book and find basically all the information about this white flange beam is in the table in the back of the book. Now the easy way to work on this problem is to make a table, something like you can do the area and then the y in this case. Now the value for x simply would be in the middle of this stress limo. Let's say this is a 30 feet long stress limo, 20 feet long, then it's going to be in the middle, the x value. So that will be in the middle. What we're doing here, we're only calculating the y center of gravity. So the distance of y from this chassis floor. So this is what we are calculating. So if you make a table like this, first you get the area and then the y and then a y, then you can simply do. So here you got three different things going on. So you have two 2 white flange beam and then 1 half-inch thick sheet across the entire bed. So the area for the white flange beam I have collected from the back of the book table. It is 32.9 inches square. So this, let's say this is my section 1, this is my section 1, the sheet is my section 3. So section 2, so my section 1, section 2, they're kind of same. Section 3 is the long bed sheet still. So the same for the second white flange beam, and for the sheet of material that would be 80 inches times the 0.5 inch thick. So that's going to be 40. The area for that would be 40. And then the Y bar from the table, I found this distance is the half of this distance. So this is D. So the Y bar for this beam would be D by 2, which I found. You can get this from the table. The D value is 11.4. So D by 2 would be 5.7. So this is 5.7. This is also for the second white flange beam, also 5.7. And for this piece right here, the half-inch thick sheet, that will be that 11.4 plus half of these. So that's going to be 11.4, the height of the white flange beam plus 0.5 by 2. If we do that, I found that 11.65. Now you can multiply this AY, this value I found 187.53, 187.53, and then this one is 4660. Sum of all this area is 841.06, and then the area moment, and then the sum of all the area is 105.8. So simply Y bar would be AY divided by A, so that would be simply 841.06 divided by 105.8. So I found Y bar is equal to 7.95 inches from the ground.